So very good evening to all of you and welcome to BYJU'S Exam Prep, my dear friends, and welcome to the session. Today we will discuss the problem solving on IP addressing. So already we covered, my dear friends, 3 to 4 session on computer network, my dear friends. In this session we will discuss very interesting problem. I will solve around 14 to 15 problems in this session, and this session is really very important, my dear friend. Those who are preparing for GATE, ISRO, BARC, NILIT or any competitive exam related to computer science. So am I audible? Everything is fine, my dear friends. Audio, video, everything is fine. So please write in the comment box, so I will continue the session. So any good evening, Tushar, good evening, Anand, good evening, Manishankar. Everything is fine. Clear, sir. Very good, very good. My dear friends, please join the session quickly. Okay. And also please share the session to your friends also, so that more and more students will join the session, my dear friends. Please share the session. If you have not liked till now, please like the session and share the session to your friends also. Okay. Also press the bell icon so you will get the notification. If you have not subscribed the channel till now, so please subscribe the channel also. So today we will discuss, my dear friends, problem solving on IP addressing. Problem solving on IP addressing. So first class we covered the introduction to IP addressing, second class classful addressing, and third class ranges of IP addresses. Is this full course? Yes. Akshay, I will cover the entire computer network, full computer network. Okay, join me every day at 8 p.m. 8 to 9 p.m. every day. Okay, 8 to 9 p.m. every day. So my dear friends, before starting the session, I want to tell you about me, myself, Ankit Doila. I have more than 10 plus years of teaching experience. I secured All India rank 159 in GATE, All India rank 119 in NET JRF. Other than the GATE and NET, I also qualified ISRO exam, NILIT exam and UPPCL exam. And my area of expertise, computer networks, theory of computation and compiler design. In this series, I will cover the computer network. Okay. So are you ready, my dear friends? Please share the session here. I want more and more students, my dear friends. एक बार ग्रुप में शेयर कर दो, टेलीग्राम ग्रुप, जहां भी आपके फ्रेंड्स हों. ठीक है, तो जल्दी सेशन को क्या कर लेते हैं, स्टार्ट कर लेते हैं फिर. ओके. Now, the first question given on the screen, my dear friends, you can see the first question. You can see the first question. What we have discussed till now in the last 3 classes, we will solve problems. When will you start TOC? TOC will be start soon, don't worry. Okay. First I will finish computer network, after that I will start TOC. So this is the first question on the screen that you can see. Okay. Find the class B address from the following. Option A, option B, option C, option D given. Class B. Which of the following is the correct answer? Give in the comment box, my dear friends. Which of the following is the correct answer? Class B address from the following. 4 IP addresses are given in the binary format and you have to find the class B IP address. Nisha Bharti C, Akila Reddy C, Surya C, Preeti C, Sohini C. Very good, very good. Very good, all of you. So now we know one thing, that my dear friends, for class A, 1 bit is 6, na? Class A, 1 bit is 6. This is nothing but 0. For class B, how many bits fix? Class B, 2 bits fix, 1 0. First 2 bits, 1 0. Class C, how many bits fix? Class C, 3 bits, 1 1 0. Class D, how many bits fix, my dear friends? Class D, 4 bits are fixed. This is nothing but 111 110 for class D. And for class E, how many bits fix here? Class E, 4 bits are fixed. These 4 bits are nothing but 41. So how we can identify any IP address belong to class B? First 2 bits must be 10. First 2 bits. Which option have first 2 bits 10, my dear friends? Which option have first 2 bits 10? This is first 2 bits 10. So we can say that this is nothing but class B IP address. Is it clear to everyone, my dear friends? Is it clear to everyone? Good, good, good. Now you can see the next question, my dear friends. You can see the next question. Find the invalid IP address from the following choice. assuming classful addressing scheme is followed. So we are following the classful addressing. Find the invalid IP address from the following choice. Which one is the invalid IP addresses? 4 options are given. Which of the following is invalid? Which of the following is invalid? Which of the following is invalid? Option A, option B, option C, option D. A, B, C, D. Which of the following is invalid? Priyanka is saying that C, Nisa Bharti C, Sahija C. Okay, very good. So my dear friends, already we know one thing that na IP address is 8-bit dot 8-bit dot 8-bit dot 8-bit. So actually my dear friends, from 8-bit what is the range here? Minimum value will be 0 and maximum value is nothing but 2 power 8 minus 1. From 8-bit minimum we can write 0 and maximum we can write 255. So any octet value is always be in between 0 and 255. Any octet value. Okay. But here my dear friends, you can see this option C. Here it is given 256. It is not possible to write a number 256 from 8-bit. Maximum number that you can write from 8-bit, this is nothing but 255. So that's why it is invalid. This is invalid. Is it clear? Question number 2 clear? So I can move to next question, my dear friends. Question number 3. Question number 3. This is the question number 3 that you can see. Which of the following addresses can be used inter-process communication in a host? Which of the following options? Option A, option B, option C, option D are given. 4 options are given here. Inter-process communication. Inter-process communication. Surya is saying that B is the answer. Sohini is saying that B is the answer. Nisa Bharti B, very good. Preeti is also saying B. Priyanka B, good, good, good. Good. Heba B, Manishankar B. Very good. So actually my dear friends, already I explained earlier na, in the last video 127.x.x.x. This is reserved for self connectivity or loopback testing, or inter-process communication, inter-process communication. So that's why for inter-process communication, my dear friend, this option B is the correct answer. Option B is the correct answer. So जिसने भी सेशन को लाइक नहीं किया, my dear friends, please like the session first of all. Like the session, my dear friends. Actually, there are only 13 like यार. Please like the session. जिसने भी अभी तक सेशन को लाइक नहीं किया, like the session. Now question number 4. Question number 4 you can see. Question number 4. Question number 4 you can see, my dear friends. I have started from basic questions so that all your concept, whatever the concept you have studied in the last 3 class, all the concept will be revised through these questions, my dear friends. Good evening, sir. 2 questions missed, first 2. Okay, Anant, don't worry, okay. Later you will get the PDF, okay. What is the answer of this question? The dotted decimal notation format for the given hexadecimal. This number is given the hexadecimal format. We have to find the dotted decimal notation. Which of the following is the correct answer? Which of the following is the correct answer? I want correct answer from all of you. Please like the session, my dear friend. जिसने भी सेशन को लाइक नहीं किया, सेशन को एक बार लाइक कर दो फटाफट से. Now, so actually, my dear friends, this is given the hexadecimal format now. C means 12. So we can write like that here. This is 1100. Hexadecimal, one number is written from 4 bit. Now C means 12. Now 2. How you can write 2 from 4 bits? We can write 2 from 4 bits. 0010. dot. Now again 2. How we can write 2 from 4 bits? 1, 2, 3, 4. Next is F. How we can write F from 4 bits? 1, 1, 1, 1. Okay. After that, this is 1. How we can write 1 from 4 bits? 000 1. Next is 5. How we can write 5 from 4 bits? 0, 1, 0, 1. Dot. Because 8 bit dot 8 bit dot 8 bit na. Now later 8. How we can write 8 from 4 bits? 1, 000. 1, 000. How we can write 2? 2 means 4 bit. 0, 0, 1, 0. Now we can convert into decimal. So this is 128, 64, 192. This is 2. 192 plus 2, 194. Dot. This is 32. And last 4 bit continuous 1 from right hand side. So last 4 bit continuous 1 from right hand side is 15. So 32 plus 15, 47. Dot. Now this is 1, 2, 4, 8, 16. 16 plus 4, 20. 20 plus 1, 21. Dot. This is 128 plus 2, 130. So which of the following is the correct answer? 194.47.21.130. This is one of the solution, my dear friends. Okay. I can tell you another solution for solving this question. Sir, listen me carefully here. Actually, my dear friends, one number I have written from 4 bit. Now one number 4 bit. Okay. So up to here this is 8 bit. Up to here this is 8 bit. This is 8 bit. This is 8 bit. Okay. So now we can say that C2. C2 is given in the hexadecimal. We have to convert it into decimal. Now 2F. We make the combination here. It is, we can convert into hexadecimal. Now after that it is 1, 5. We can convert into hexadecimal, into decimal. Okay. Now after that this is 8, 2. 8, 2 we can also convert here. It is given the hexadecimal. How we can convert into decimal, my dear friends? It is really very simple. 16 power 0, 16 power 1. So C means 12. 12 into 16 power 1 plus 2 into 16 power 0. Like that we can convert here. 12 into 16, this is nothing but 190. 2. 192 plus 2, this is nothing but 194. Okay. Now we can also find like that. 16 power 0, 16 power 1. So this is nothing but, my dear friends, here 2 into 16 power 1 plus F means 15, 15 into 16 power 0. So this is nothing but 32 plus 15. This is nothing but 47. So second octet value we got 47 now. So this is nothing but 16 power 0, 16 power 1. So 1 into 16 power 1 plus 5 into 16 power 0. So this is nothing but 16 plus 5. 16 plus 5 is nothing but 21. Okay. Now it is given 82 also here. So actually from this you got one idea. Now my dear friend, this is 16 here. So this is first number. First number whatever is C. C means 12. We are multiplying with 16. Second 2. 2 into 16 power 0. 16 power 0 means no effect here. Power 0 means one value here. Whatever the value you are getting, suppose it is 2. Multiply with 16. And add this F means 15. Add this number. First number 16 na. 16, 1 into 16 plus 5 only. So same as it is here, this is how we can convert na. This is 8 into 16. And whatever the number it has written na here, add like that. So this is nothing but 130. 16 into 8, 128 plus 2, 130. Is it clear or not? It is really very simple. My dear friends, like this session. जिसने भी session को like नहीं किया, please like this session. Okay. Now another question. Now this is the question, my dear friends. I want a correct answer from all of you. This is the one of the good question. I want a correct answer from all of you. Okay. Correct answer from all of you. This question. And within 30 seconds, I want correct answer. Within 30 seconds. You can apply any approach, but second approach is better. Second approach, this is. You can simply find the answer. This is the question number 5 that you can see. Question number 5. Question number 5. Question number 5. Akhila Reddy is saying that B is the answer. Any other? Anyone? Surya is also saying B. Very good. Sneha is saying B. Nisa is also saying B. Very good. Now, so actually, my dear friends, how we can find now? This is 1 7. Make this 1 7 2A 8 4 C8. So this is written here 1 7, and it is written in the hexadecimal now. How we can convert into decimal? First number multiply with 16 plus write second number as it is. So this is nothing but 23. Now this is 2A na here 2A. It is 16. First number multiply with 16. 2 into 16 plus A means 10. So this is nothing but 42. Now after that this is 8 4. 8 4 is written in the hexadecimal. First number multiply with 16. 8 into 16 plus 4. This is 132. Now next is C8. It is given the hexadecimal. First number C means 12. 12 into 16 plus 8. 12 into 16 192. 192 plus 8. This is 200. So first octet this is 1 7. 1 7 means 23. Second octet 42. Third octet 132. 200. That B will be the correct answer. Is it clear to everyone, my dear friends? Question number 5 is clear to everyone. Question number 5. So I can move to next. Question number 6. It is interesting. This question is interesting. Question number 6 is interesting. Suppose instead of using 16 bits for network ID part for class B, 20 bits has been used. Then number of class B networks and host per network are. So what they are saying that normally in the class B network ID is 16 bit, host ID 16 bit. But what they are saying that we are not using 16 bit network ID for class B. If we take 20 bits network ID for class B, so remaining 12 bits represent host ID, then number of networks and number of host per network. Then number of networks and number of host per network. It is interesting. Tell me the answer, correct answer for this one, my dear friends. Which one is the correct answer? Number of networks they are asking and number of host per network. Anand Kumar is saying that C is the answer. Okay. Anyone? Preeti is saying C. Manishankar C. Very good. All of you. My dear friends, please share the session to your friends also, yaar. Nisa C. Very good. So actually, my dear friends, we know one thing that na class C network ID is 16 bit and host ID how many bits? 16 bit. We know this thing here. Class B. They are saying that class B, not class C. Class B. This is network ID 16 bits. Host ID 16 bits. Okay, this is network ID 16 bit, host ID 16 bit. But in the class B, 2 bits already fixed na here. So how many remaining bits, my dear friends? Remaining bits are 14 bits. So number of networks in the class B, number of networks equal to 2 power 14. We know. And this is 16 bit host ID. So number of host per network, number of host per network, number of host per network. How many, my dear friends? Number of hosts they are asking. So this is nothing but 2 power 16 minus 2. Already we studied this or not? Yes, sir. But what they are saying that we are not using 16 bits. What we are using, my dear friends? We are using 20 bits for network ID. So actually if we are using 20 bits here for network ID, so remaining 12 bits are representing host ID. If this is network ID and this is host ID. But in the class B, 2 bits already fixed. 2 bits already fixed here. If 2 bits fix 1 0, so how many remaining bits, my dear friends, here? Remaining bits nothing but 14 bits. sorry, 2 bits fixed, remaining bits nothing but 18 bits. And this 12 bits here remaining host ID part. So from 18 bits, how many number of networks we can make here? Number of networks equal to 2 power 18. And host ID 12 bits, my dear friends. So number of hosts per network, how many? Number of hosts per network. Number of hosts per network equal to 2 power 12 minus 2. So that's why correct answer for this question will be C. Correct answer for this question will be C. Is it clear to everyone? Correct answer for this question will be C. Is it clear? So I can move to next question. Question number 6 is clear, so I can move to next question. If 20 bits network ID, 2 bits already fixed, na? So how many remaining bits? Remaining bits will be 18 in the network ID. So number of networks 2 power 18. Host ID how many bits? 12 bits. Number of hosts per network 2 power 12 minus 2. Why 2 power 12 minus 2? Because first whenever we have all zeros in the host ID part or all ones in the host ID part, we cannot assign to any computer. Okay, these are for some special purpose. Now this is question number 7. It is interesting. Question number 7. My dear friends, please like the session here. जिसने भी सेशन को लाइक नहीं किया, प्लीज लाइक द सेशन. ओके, क्वेश्चन नंबर 7. नंबर ऑफ नेटवर्क्स एंड नंबर ऑफ होस्ट इन क्लास बी are 2 power m or 2 power n minus 2 respectively. Number of networks and number of hosts per network in class B. Tell me the answer. Correct answer for this question number 7. Correct answer for this question number 7. Surya is saying that B is the answer. No. B is not the answer. Maybe that, I'm not sure yaar. Maybe that B may be the answer. Okay. Because answer मुझे भी याद नहीं रहते, कुछ भी हो सकता है. But you have to solve. You must have a proper logic. Okay. Number of networks and number of hosts in class B. 2 power n and 2 power n minus 2 respectively. Then relation between m and n. What will be the relation between m and n? Manish Shankar is saying that C is the correct answer. Manish Shankar, C. Very good. Ikra is saying that C is the answer. Very good. Tushar Sisodia is saying C is the answer. Very good. Class B, they are asking, my dear friends, class B. So we know one thing, that here number of networks in class B, what they are saying, that 2 power m. Number of hosts per network, it is number of hosts per network in class B. How many? Equal to 2 power n minus 2. So my dear friends, actually reality, how many number of networks in the class B? Class B, how many networks? 2 power 14, na? And number of hosts per network, it is 2 power 16 minus 2. So my dear friends, we can find easily here m and n value. So it means 2 power m. So here number of networks are 2 power 14. So it is really simple. M value is nothing but 14. Number of networks 2 power n minus 2. How many? Number of hosts per network 2 power n minus 2. And how many number of hosts per network in class B? 2 power 16 minus 2. So we got here n value. This is nothing but 16. So we got m equal to 14 and n equal to 16. If I do m by n here, this is nothing but 14 by 16. So we can say that m by n equal to 7 by 8. So what we can say? We can say that 8m equal to 7n. 8m equal to 7n or not? So which of the following is the correct answer, my dear friends? Correct answer for this question will be C. Is it clear to everyone? Is it clear to everyone? Question number 7. So I will move to the next question. Question number 7 is clear. Question number 8. Question number 8. How many networks are possible in class B addressing system? How many networks are possible in the class B? It is really very simple. How many number of networks in the class B? I want correct answer from every students. Correct answer from every student. Number of networks in the class B. Number of networks in the class B addressing system. Nisa is saying B, Akhila, Anand, Priyanka, Sakshi, Anand, Ikra, Surya, everyone. Yes, number of networks are 2 power 14 here. In the class B, network ID, how many bits? 16 bits. But 2 bits already fixed. So how many remaining bits? Remaining bits nothing but 14. So number of networks in the class B always 2 power 14. Already we cover in the previous class. Last class already we cover. It is really very simple. Now, question number 9. How many number of hosts per network in class C? How many number of hosts per network in the class C? Tell me the answer. I am waiting. Class C. So class C network ID, my dear friends, how many bits? 24 bit. Host ID, how many bits? 8 bit. So number of hosts per network, how many? Number of hosts per network. Number of hosts per network, how many? Equal to 2 power 8 minus 2. 2 power 8 minus 2. Class C na D will be the correct answer. So D will be the correct answer. It is really very simple question. D will be the correct answer. Clear to everyone? Now question number 10. Question number 10. You can see this question number 10 on the screen. A host with IP addresses 10.100.100.100 wants to use. This is the question number 10. Question number 10 you can see. A host with IP address this 10.100.100.100 wants to send loopback testing. Want to use loopback testing. What are the source and destination address? Source address and destination address. Assuming classful addressing is followed. If this host want loopback testing, yesterday class I discussed na. So what will be the source IP? Source IP address is nothing but his host IP address will be the source IP address. Yesterday I discussed na, this is A. This is the router here. This is the B. Host B. Suppose this have this IP address. What is given here? 10.100.100.100.100. Loopback testing. Like that. Yesterday I discussed here. So for this, my dear friends, what will be the source IP address? Source IP is nothing but this IP address of this host here. 10.100.100.100. What will be the destination IP address? I told you na 127.x.x.x will be the destination IP address. So now option A. Source is this, destination is this. No. This will be wrong here. Loopback testing means destination address will be 127.x.x. This is 255.255. No. This is 127.1.100.1. Yes, this will be the correct answer. Source IP, this not be 127. Destination IP. 127 will always be used as a destination IP. 127 cannot be used as a source IP. Always remember this point. You can write one point on the note. 127.x.x.x will always be used as a destination IP. So is it clear to everyone, my dear friends? Please like this session. जिसने भी सेशन को like नहीं किया, my dear friends, please like this session. Now, question number 11. How many bits are allocated for the network ID and host ID? How many bits are allocated for the network ID and host ID? In 23.192.157.234. So जिसने भी अभी तक सेशन को like नहीं किया, please like the session, my dear friends. How many bits are allocated for network ID and host ID? In 23.192.57.234 address, assume classful addressing scheme is followed. Surya is saying that C is the answer. Anyone? Any other? C. You are saying that C is the answer. Nisa Bharti, C. Ikra, Akhila, everyone. Very good, very good. Very good, all of you. So actually this 23, my dear friends, this 23 is first octet. If first octet value is in between 1 and 126, if first octet value is in between 1 and 126, so we can say it is class A. We can say it is class A. And class A have network ID and host ID how many bits? Class A network ID 8 bit. This 8 bits represent network ID and 24 bits represent host ID. 24 bits represent host ID. So correct answer for this question will be C. Correct answer for this question will be C. Is it clear to everyone? What is my motive? My motive is here in this class that whatever we have studied in the last 3 class, all the concept will be revised. Okay, this is my main motive, that you will not do any mistake in the basics. Now, this is the question. In classful addressing, a large part of available addresses are dispersed, blocked, wasted, reserved. This is also another interesting. This is also interesting question, my dear friends. Question number 12. Question number 12. Tell me the answer for question number 12. Classful addressing, a large part of available addresses are reserved, wasted, blocked, classful addressing scheme. D. D is not the correct answer. D is not the correct answer, my dear friends. Let me show you here. So actually classful addressing, how many IP addresses we have? 2 power 32. Okay. So if I choose 1 bit here, I will divide this block into 2 parts. Okay. And again, so in this part, this bit will be 0. In this part, this bit will be 1. This is the case here. Again, this is the space. We have fixed this part for class A. Again, this is space. If I choose 1 bit here, again this will be divided into 2 parts. In this part, we can write this value 0. In this part, we can write this value 1. And this space we have reserved for class B. This is the case or not? Yes. Now again, this is the space here. If I choose 1 bit here, again this space will be divided into 2 parts. So in this part I can write 0 and in this part I can write 1. And this I have fixed for class C. Now again, this is the one space. If I choose 1 bit here, again this space will be divided into 2 parts. In this part I can write 0, in this part I can write 1. This space we have reserved for class D and this space we have reserved for class E. Already we studied, my dear friends. Okay. Now we know one thing, that here I told you that class A have how many IP addresses, my dear friend? Half. 2 power 31 IP addresses available in the class A, 2 power 30 IP addresses in the class B, 2 power 29 in the class C, 2 power 28 in the class D, 2 power, because it have 2 power 31, it have 2 power 30, class C have 2 power 29, class D have 2 power 28, it also have 2 power 28. Is it or not? Yes, sir. Now further what we have done now, it is really important. Later we have divided this class into networks. Class A, how many networks, my dear friends? Class A, how many networks? 0 to 127, but 0 and 127 cancelled. 126 networks practically possible. So again, my dear friends, again we have divided this class into number of networks, like that. Number of networks. Class A, we have divided into number of networks. Number of networks. Many number of networks. And can you tell me one thing, that what is the size of one network? What is the size of one network? Class A. Class A network ID 8 bit. Host ID how many bits? 24 bits. So from 24 bits, how many combination we can make? 2 power 24. So in one network, how many IP addresses we have? 2 power 24 IP addresses we have. But out of 2 power 24 IP addresses, first IP address we cannot assign to any computer because we have all zeros in the host ID part. And last IP address we cannot assign to any computer because we have all ones in the host ID part. But total number of IP addresses available in the class A is 2 power 24. If anyone asks now number of IP addresses available in one network of class A, so answer will be 2 power 24. If someone asks number of host per network in the class A, so answer will be 2 power 24 minus 2. This is really very important, because 24 bits we can make 2 power 24 IP addresses, but out of 2 power 24 IP addresses, first and last IP addresses we cannot assign to any computer. I hope you are getting my point. So if someone asks IP addresses in one network, to how many, my dear friends? 2 power 24. 2 power 24 IP. If someone asks host, so you can say 2 power 24 minus 2. Okay. Now again, this class B is further again divided here into networks. Class B again further divided into networks. Divided. Many networks. Can you tell me, my dear friends, what is the size of class B? Class B host ID how many bits? 16 bit. Number of IP addresses possible? 2 power 16. Okay. In one network, but number of hosts per network 2 power 16 minus 2. So in one network of class B, this is nothing but 2 power 16. Now again further class C is divided here again. Class C is also further divided into networks, like that. Class C, what is the one network size? Class C, one network size is 2 power 8. One network have 2 power 8 IP addresses. So now in the classful addressing we have choice. Either we can take class A network. Practically how many network of class A are available? 126. Either we can take class B network. Class B network how many? 2 power 14. Either we can take class C network. Class C how many networks? 2 power 21. Now actually, my dear friend, why? Actually suppose if there is a organization X, listen me carefully. If any organization X want 500 IP addresses. How many IP addresses organization X want? 500. So we cannot assign class C network because class C how many IP addresses available? 2 power 8 256. So we have to go for class C network, because suppose if in your company have 500 computer, you want 500 IP addresses for 500 computers. So class C you can't take class C network because class C how many IP addresses available in one network? Only 256. So you have to go for class B. If you purchase class B network, what is the wastage, my dear friends? Can you tell me wastage? How many IP address? 2 power 16. 2 power 16 is 65,536 minus 500. 65,036 IP address wasted. Suppose there is an organization Y. needed 70,000 IP addresses. 70,000 IP addresses. So class B network is not enough, because class B, how many IP addresses available here? How many IP addresses available in the class B? Only 65,536. So we have to go for class C. If we take class C network, my dear friends, so how many networks, how many IP addresses available? 2 power 24, approximate 1.6 crore. So 2 power 14. What is the wastage here? Wastage 2 power 14 minus 70, sorry, 2 power 24 minus 70,000. 1.6 crore minus 70,000. Lots of IP address wasted. Lots of IP address. So my dear friend, that's why the correct answer for this question is wasted. In classful addressing, a large part of IP address is wasted. This is the drawback of classful addressing. I hope now it is clear. Question number 12 is clear, I hope. जिसने भी सेशन को लाइक नहीं किया, my dear friends, please like the session. Now question number 13. Let's read the question number 13. Read the question number 13. What is the possible number of networks and addresses each network under class B? Class B. Class B. Number of networks. Possible number of networks and addresses. This is also interesting. This is also interesting. I want correct answer from you. I want correct answer from all of you, my dear friends. This is also interesting question. Tell me the correct answer. What is the possible number of networks and addresses in each network? Some of the students are saying that correct answer for this is C, and some of the students are saying correct answer for this is D. Let's think. Read the question carefully, my dear friends. Reading the question carefully is really very, very important. Don't forget to read the question properly, because what they are saying that class B network ID, how many bits? 16 bits. Host ID, how many bits? 16 bits. But my dear friends, actually 2 bits already reserved na in the network ID. So here this is network ID. If 2 bits already reserve 10, how many remaining bits in the network ID? 14 bits. And these remaining 16 bits are representing host ID part. So number of networks will be 2 power 14. Number of networks equal to 2 power 14. And actually in this question what they are asking, number of networks and addresses in each network. They are not asking host in each network. They are asking, my dear friends, addresses. Addresses means IP addresses. So actually from 16 bit, number of IP addresses per network. Per networks equal to 2 power 16 only. If they ask number of host, so it means answer will be 2 power 16 minus 2. So correct answer for this question will be D. Correct answer for this question will be D. Is it clear to everyone? So I can move to next question. Question number 14. IP address 200.198.32.65 belongs to which class? Belongs to which class? I want correct answer from all of you within 30 seconds. Within 30 seconds. जिसने भी सेशन को like नहीं किया, my dear friends, please like the session. See, So actually we know one thing that na class A, what is the range of class A? 1 to 126. Its first octet value is 1 to 126, that is class A. What is the class B range? Class B range is 128 to 191. So your range will be revised here. Now you will not forget after this. Class C range 192 to 223. Class D 224 to 239. And class E. Class E, my dear friends, 240 to 255. So 200 comes under which? 192 to 223. It means class C. Correct answer for this will be class C. Is it clear to everyone? Is it clear to everyone? नहीं, दो बार नहीं करना, एक ही बार करना है बेटा. बच्चे उस्ताद हो गए हैं आजकल. मास्टर को भी चला दें. Now, next question. Percentage of address occupied by class D. Percentage of address occupied by class D. Class D. Percentage of addresses occupied by class D in classful addressing system. Classful addressing system. Already we covered now this. So initially, my dear friend, this is like that. Now it will be like that. This is half we have assigned to class A, and after that this is quarter. Okay, this is the case. Now we know one thing that, my dear friend, this 50% we have assigned to class A. This is class A, so this is nothing but 50% IP addresses. This is half, and this is space we have reserved for class B. So this is quarter. It means we can say 25%. This is for class C. We can say this is 12.5%. Already we explained now this concept. And this is for class D. This is for class E. So it means 6.25%. Here also 6.25%. Okay. So correct answer for this question will be C. Question number 15. Is it clear to everyone? Question number 15 is clear to everyone? Very simple. Okay. Now, next is question number 16. This is one of the previous year gate question. This is one of the previous year gate question. In IPv4 addressing format, number of networks all allowed under class C. Under class C, how many networks allowed? माय डियर फ्रेंड, जिसने भी सेशन को लाइक नहीं किया, प्लीज लाइक द सेशन. और यार सेशन को टेलीग्राम ग्रुप में भी, जो आपके टेलीग्राम ग्रुप हैं, सब जगह शेयर कर दो दोस्तों, जिससे कि ज्यादा से ज्यादा स्टूडेंट जुड़ जाएं. ओके. क्लास सी, so my dear friends, actually we know one thing that here network ID, how many bits here? 24 bit in class C. Host ID, how many bits here? 8 bit. We know that. But first 3 bits already fixed now, 110 in the class. So how many remaining bits? Remaining bits are nothing but 21 bits. And this is host ID. So 21 bits, how many networks are possible? Number of networks. Number of networks equal to 2 power 21. Is it clear to everyone? So correct answer for this question is D, not the A. Okay. Correct answer for this question will be D. 2 power 21 will be the correct answer. Okay. Now, So my dear friends, if you have not downloaded till now the BYJU'S Exam Prep, so you can download the BYJU'S Exam Prep from Play Store, my dear friends, and don't forget to like and share the session. Okay, so my dear friends, it is your responsibility. Okay, ये आपकी रेस्पॉन्सिबिलिटी के सेशन को सिर्फ शेयर करना है. हम फुल कंप्यूटर नेटवर्क पढ़ेंगे, लेकिन सिर्फ और सिर्फ एक कंडीशन है. इफ नंबर ऑफ स्टूडेंट्स विल बी मोर, नंबर ऑफ स्टूडेंट ज्यादा रहेंगे तो मेरा भी मोटिवेशन बढ़ता रहेगा. ठीक है, माई मोटिवेशन विल बी मोर. ओके, सो आई वांट ओनली मोर एंड मोर स्टूडेंट. Same session for compiler design also required. Manish Shankar, I will teach computer network first, later theory of computation. Sorry. Later theory of computation and later compiler design. Okay. So first I will finish computer network. Okay. So I want more and more student here. सिर्फ आपको क्या करना है? You have to share the session. Okay, to all your friends. ठीक है. अदरवाइज बच्चे कम आएंगे तो मेरा मोटिवेशन जाता रहेगा. ठीक है. HPCL के लाइव कुछ प्रैक्टिस सेशन. राजा बाबू, ओके, नाइस सजेशन. आई विल डिस्कस विद द टीम रिगार्डिंग HPCL. सबको मालूम नहीं चला अभी तक, लगता है when they come to know that you are teaching CN they will must join. अनंत, this is your responsibility यार. ऐसा करो ना, you have to tell your friends that I have studied CN. प्राज्वल, वेरी गुड, थैंक यू. हाँ, ये बोलना है बिल्कुल. ऑलरेडी 4 सेशंस हो चुके हैं, हम कंटिन्यू करेंगे. ठीक है, तो इसलिए अभी आप बोल दो जिससे कि स्टूडेंट्स लाइव भी अटेंड कर पाए. इट विल बी वेरी गुड. ओके, इट विल वेरी गुड फॉर स्टूडेंट्स, माय डियर फ्रेंड्स. सो अभी कोर्स पीछे नहीं गया है. 4 लेक्चर्स हैं 1 आवर की ओनली. सो कोई भी स्टूडेंट एक दिन में कर सकता है और आफ्टर दैट लाइव भी ज्वाइन कर सकता है मेरे साथ के साथ. तो अभी आपको क्या है, शेयर करना है. शेयर एंड रिकमेंड आल्सो. ओके, ऐसा नहीं कि बस शेयर कर फॉर्मेलिटी कर दी. ठीक है, आपको रिकमेंड करना है. बस आई वांट ओनली दिस मोटिवेशन. बस आपसे ये मोटिवेशन है मुझे. ठीक है, बस कि आप ये शेयर कर दो. बस जितने ज्यादा बच्चे होंगे उतना ही एंजॉय आएगा, उतना ही मजा आने वाला है. ठीक है, ठीक है दोस्तों, चलो मिलते हैं कल. ओके, टुमारो आई विल मीट यू 8 PM. टुमारो 8 PM. with the another session. Tomorrow I will discuss problems in computer network. I will tell you regarding the problems with computer network: identification problem, communication problem, and connection problem. So tomorrow class will be problems in computer network. Computer network have 3 problems: communication problem, how we can communicate; identification problem, and connection problem. So tomorrow we will discuss these 3 problems, and after that we will discuss types of communication. Okay, so thank you all. We will meet you tomorrow at 8 PM. Okay, don't forget to like the session and share the session to your friends. Thank you very much for attending the session, my dear friends.